Hey everybody, today I'm going to find the area of a circle given that we already know that the circumference is equal to 2 pi r, where r is the radius of the circle. Okay, so 3 Blue 1 Brown did a derivation on his first video of the calculus series, the essence of calculus. He showed a very elegant proof, and it looks really nice with the animation and all that, using concentric rings, okay? In this video, I'm going to talk about another approach, and it's going to be by dividing this into some triangles. Okay, so pretty much what I mean is that I'm going to take, so now I kind of divided the circle into 4 pieces, and they're not triangles, obviously, because this is not a straight edge. But if we take the number of divisions and we make it go to infinity, then we can approximate each one of these by a triangle, because then we're going to have a smaller and smaller sliver, and it's going to be more like a straight edge. And we can do that. We can kind of do that using limits. So I want to denote n as the number of divisions of the circle. So that's how many times I'm dividing it. And we know that the circumference is 2 pi r. Let me make that a little better. And so how are we going to find the area? Well, we can take one of these triangles and we can approximate something like that. That is our base, right? Something like that, basically. And it's going to be a fraction of the circumference, right? Because we're taking the limit as n approaches infinity of n. So we're taking the number of cuts and we're going to do it as many as we can, basically. And so this base here, right now it's not the same as the arc over here, but like I said, as we go to infinity, we can basically say that they're the same thing. So we can approximate this by saying that this is a portion of our circumference. So that particular portion is going to be 1 over n times 2 pi r. So if the entire circumference is 2 pi r, and right now we have 4 divisions, that's going to be 2 pi r divided by 4. Okay. Yeah, I just realized, that's not actually going to be 2 pi r divided by 4, that's 2 pi r divided by 8. So, yeah, because basically I defined a division to be like the whole thing, but I think it's best to say that any division from the center to the outer edge, the outer ring, that's going to count as a division. So this is 2 separate divisions. So right now we have 8 divisions here, okay? So let's just stick with that convention. Or we could say that a whole division is here and then multiply it by 2, and it doesn't really change anything. But yeah, so let's say right now we have 8 divisions, so this is going to be 2 pi r over 8, okay? And so let me just write this as 2 pi r over n, just to be more concise that way. And then the radius is obviously r. That's what we define that to be. And so the area of one triangle, which I'm going to call A0, or actually I'm going to call it A sub capital N, so one particular triangle when we're working with capital N, so it's a function of that, basically. A sub n is going to be 1/2 times the base, which we said is 2 pi r over n, times the height of that triangle, which is the radius. So we'll make that better than r, okay? So this 1/2 and this 2 will cancel, and we get pi r squared over capital N. So this is the area of one of these triangles. We want the area of all of them, so all we have to do is multiply by n. So if we get the area of the circle, this is going to be n times the area times a sub n. So we got NaN there. And so pretty much we're going to take this and multiply it by capital N. And so it's going to cancel out with the numerator and the denominator. So in the end, we're just going to get pi r squared. And this is the area of a circle. And yeah, I didn't do it totally formally because I should have included some limits here and all that. But this is kind of the general case, and you can do that with, this is, whenever we do it with a finite n, if we say like n equals 100 or something, this is going to be an approximation. However, when we take the limit as n goes to infinity, then it's exact. So technically, I guess I should put like a limit here, here, and pretty much everywhere here. But I just wanted to kind of show you that little trick, and you didn't have to involve any integrals, though you could. You could think of taking this as some sort of integral, being like a sub n plus a sub n amount of times, and then you can like integrate that, but you're going to get this in the end. So yeah, just a little exercise there. Just wanted to make a short little video, so thank you guys so much for watching, and I'll see you in the next one. Bye guys.